A warm welcome to all the students. A very good morning, good afternoon and good evening to all the participants. This is the course titled Multi-Criteria Decision Making, and as you know, this is a 60 set of lectures spread over 12 weeks, and each week we have 5 lectures, each lecture being for a half an hour. And as usual, I am repeating it, please excuse me for that. There are assignments for each week. So, 12 assignments and there is a end sem. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, even though the broader umbrella or the superset under which we are discussing is written there, so that is basically throughout almost the set of lectures. So, because in the first part there was examples, then there was utility function which was quite given for whole set of slides, and then we switched over to multi-criteria decision making, and there were two important points. One was multi-objective and one is multi-attribute. We are only discussing multi-attribute now. And the last class we started the TOPSIS method. So, the TOPSIS method idea, even though I am going to start from the new slide, but the slides which you already remember I will discuss. So, there is X matrix which gives the overall scores, and scores are based on the utility function, the concept between the alternatives and the criteria. That is point 1. Point number 2 is that you will give, or the decision maker will give also weights for each and every criteria. So, important criteria higher weights, less important lower weights. We will also use the concept of normalization. Normalization would be depending on how you portrait the X matrix. It can be along the rows or along the columns, and then we will multiply the normalized matrix with X, find out the new matrix, and then utilize the so called multiplicative factors of the weights and the normalized matrix, and then try to rank them. Also remember, both positive and negative concept are being used, so which is the positive distance and the negative distance, or the concept of PIS and the NIS. So, the idea which we are still continuing is the technique for order preference by similarity to ideal solution, which is the TOPSIS. Now, as we give the, and if you remember, we have discussed the simple pseudocode, and that was the idea which is being repeated. So, I will give the general formulation and then consider the problem. So, assume the decision matrix is given like this. So, if you see this matrix, it is of size m cross n. So, technically the matrix which I am talking about, I will use the black color, and these are the alternatives. So, there are alternative 1. So, if there are m number of alternatives, so along the rows there would be m numbers. So, A1 till AM, m small m or capital M, and on the columns I will use the blue. So, it is C1 to Cn, n as in Nagpur. So, these are the criteria. So, when I consider any value, see for example, x11, I will write in black, x11 would mean what is the overall benefit or of criteria 1 on alternative 1. Now, if I want to consider only the alternatives, so only concentrate on the rows. So, the first row, if I consider this part, I will use the light yellow color, so it is easier. So, this one. So, the first one is x11, which is for criteria 1, weight or overall weightage or the points for the first alternative. Similarly, when I go on the same row, the second value, so this will be x12, because this is 2. So, this is the overall weightage for the second criteria on alternative 1. Similarly, I go to the last one, which is x1n. So, technically all the points which are there, scorings which are there for x11 to x1n are corresponding to the first alternative. If I consider the last column, the corresponding values are xm1, xm2 till the last one, which is xmn. So, which means that this set of benefits or the points which are being assigned for the by the criteria C1 to Cn are corresponding to the alternative m only. So, that is why it is m cross n. So, if the number of alternatives, the number of criteria was same, so it would have been a square matrix. Now, convert the entries in X into a normalized scaling. Now, normalized scaling can be different ways. I will write them accordingly. First, let me erase this part. So, when I use the normalized scoring, it is one score can be Rij as given here. So, basically the value xij divided by square root of the sum of the squares. Another can be, say for example, just it can be xij divided by just the sum. It can be a normalization factor concept also. Another can be Rij is equal to ln of xij by sum of ln, Neperian log or log. So, this concept of trying to normalize would depend on the values of the cells which are there. So, when I talk about the values, the utility one concept, they would change depending on the criteria which you are considering, or the weights you are giving, or the importance you are giving. So, convert the entries into X into a scale normalized one, and once you have that, you have the matrix which is bold R. So, if you remember, I mentioned that you have to multiply the weights with the normalized matrix X, that normalized matrix is R. So, once you normalize, you will get the R matrix. Now, the question is, the normalization has to be done row wise or column wise. That would depend on how the overall the values of x had been given to you. It could have been like here, if you remember, the problem is there are m number of alternatives and n number of criteria. So, m was in the rows and n was in a column. What it was just flipped, transpose of that. So, in that case, n as in Nagpur would be measured along the rows and m would be along the columns. So, in that case, your concept of normalization would change from row to column, column to row, depending on how the nomenclature or the points have been considered. So, as I said that I will have values also to discuss. So, if I consider the values, so assume x is given by the score system as, which is basically there are 4 rows and 5 columns. So, this is 4 cross 5 and the scores are given. If I read it, the first column was 10, 5, 15, 20, 25, the second column is 25, 15, 25, 30, then the third column is 25, 35, 40, 30 and so on and so forth. Now, what does it mean? It means that if I only consider column 1, which is basically criteria 1, then the overall benefit which you will get based on the fact that somebody is analyzing the problem only from criteria 1 perspective for the alternatives would be as follows: 10, I am reading the numbers, 10 for assignment for the alternative 1, 5 for alternative 2, 15 for alternative 3, 20 for alternative 4. Similarly, which means that technically the overall value which you will be assigning based on criteria 1 goes highest to alternative 4 here. Similarly, if you consider the second column, third column, fourth column, fifth column, the corresponding values which you will get for giving the maximum scores would be for the second column, which is C2, again it is basically the last alternative. Similarly, if I consider the criteria 3, which is the third column, the best score is given for the third alternative. Similarly, for the other two criteria, the best score would be corresponding to the again third alternative, because it is 45, and then in the last case it will be corresponding to the first alternative. So, scale the values using the normalization factor, and I do that. When I do that, obviously these normalization factors which are to be considered as the case. So, let me do the normalization in an Excel sheet. So, it will be easier and understood by all. I will take a very simple problem. So, simple problem in the sense we can consider this. So, I will put x here, I will zoom in the value, so it is for better visibility. So, here I will consider alternative 1, A1 is alternative 1, A2 is alternative 3, A3 is alternative 3. Similarly, C1 criteria, C2 criteria, C3 criteria, C4 criteria, C5, and that is why it is 3 cross 5. The scores are given as 10, 5, 15, there is, I am considering what another one also, it is 4. So, they would be A4. 20 for criteria 2, 25, 15, 25, 15, 25 and 30. So, criteria 3 is 25, 35, 40, 35. Wait, let me check 1, 2, 3. This is 10, 5, 15, 20, 10, 5, 15, 20, 25, 15, 25, 30. Then is 25, 35, 25, 35, 40, 30. This would be 30. Sorry, my apologies. Then I go to the fourth column. It is 30, 40, 30, 40. 45, 35, 45, 35, and the last one is 15, 10, 10 and 5. You see it. Now, the normalization which is done here, so I am going to change it, and also, so let me consider first R. So, I have so I am going to consider normalization happening based for the criteria. So, I am going to normalize the criteria and then consider for the alternatives. So, if I consider the simple normalization, let me write it also, so there is no confusion, because when you see the videos it will be easy for you to understand. So, let me consider normalization 1. So, normalization 1 would be basically be given as this. So, I will use this normalization 1 concept here. This is equal to 10, which is cell first, divided by sum of all the values which is there in column 1. So, I fix it because the sum is fixed. So, I fix it and then I copy it for the first column. Now, for just double checking, the sum is 1, what you see. So, I will mark it with a light yellow color. So, this cell when is copied, is not copied, I have to change it. So, this basically would become the values corresponding to D. So, this is also 1. Then I copy it for to the third column, again I change it. So, this would be E, this is also E, so this is also normalized. When I go to the, so this would be column F, again normalized 1, and when I consider G, so again normalized. Now, what does technically normalization mean? If I consider this, which I will just highlight with a color, but I will remove the color accordingly. So, consider I am highlighting with this color, and should I zoom in more. So, it means that if I consider criteria 5 only, and on the normalized scale or so called importance scale, for each alternative, these are not the weights for criteria. So, for that criteria, the overall so called normalized importance, let me use the word importance, which is being placed for A1, A2, A3, A4, which is alternative 1, 2, 3, 4 coming out from C5 called criteria 5, are given as 37.5, 25, 25, 12.5, which means the highest amount of importance is being given to alternative 1 based on the fact C5 is being considered as the criteria. If I consider this, as I said, I will remove the color. So, there is no fill. If I go to this, so here for C3, which is the criteria 3, the corresponding importance is highest for alternative 3, then it is for alternative 2. Why 3? Because it is 30.7. The second one is 26.9 for alternative 2. The third is for alternative 4, 23.07, and the last one is alternative 1, 19.23. So, if I remove again this color, now with this also I have a weight, and this weight there is some ideas which I want to give. So, these weights are basically the criteria weights, the importance you are going to. So, for me selecting the final answer is the alternative, not the criteria. So, my importance would be placed on the criteria based on which I am getting the alternatives. So, obviously, if there are 5 alternatives, there would be 5 weights. So, let me consider the weight matrix. So, this you have C1, let me remove this one cell onto the right. And this is the weights which I will put the capital W. Now, a question would definitely be asked from your side, which I will answer, but not solve problem accordingly, which will come, the question will come later. First, let me put it. Consider I am putting weights as 10% for alt criteria 1, 20% for criteria 2, 10% for criteria 3. So, 2 0.1, 0.2 which is 0.3, 0.3 plus 0.1 is 0.4, this is 0.3 for C4. So, 3, 4, 5, 6, 7 and the last one will be also 0.3. Now, what does it mean? So, I have not put other values. So, if I consider this principal diagonal, which means I am putting 10% weightages for criteria 1, 20% for criteria 2, 10% for criteria 3, 30% for criteria 4, 30% for criteria 5. So, corresponding to this, the other values would be 0. Now, there would definitely be a question which I said which may crop up, which I will try to explain. Now, the question can come up, is it possible for a human being to change the criteria weights itself depending on the alternatives? It is possible. Like if I prefer a car made by, say for example, Tata Motors, and I am trying to compare, then I may be willing or may tend to give more weightages for Tata cars for the same criteria, because say for example, the style concept is very good. I am giving an hypothetical example. So, but this point, when I am changing the weights based on the criteria and alternatives would be true when I am considering a whole set of gamuts of cars by different make. When I am considering the car for only one company and I want to choose, which is the rarity, because in front of me there would be different cars from different makes. So, in those rarity cases where only one set of alternatives are there for buying a car where the manufacturer is the same, then only this both theoretically and practically sense would make true, but we will stick to that and continue. The reason is that matrix multiplication where rows and columns are important is maintained. So, if I consider the multiplication, so I consider this matrix as Y. If I say matrix, so matrix multiplication so this is basically the matrix multiplication, and here you will understand. So, if I multiply the concept, and by the way this matrix multiplication, this is basically of size 4 cross 5 and that weights for the criteria is 5 cross 5. For 4 cross 5 should be multiplied pre and then 5 cross 5. So, the end result is 4 cross 5. So, let us check 4 cross 5 if whether is yes. Yes, it is. There are 4 rows and columns, 5 columns. So, not the other way around. So, it is not basically 5 cross 5 into 4 cross 5, because that incompatibility would be there. So, once you have this, these are the multiplication of the normalized score with the weights, which is important, and we will consider and marking it as Y. So, if I consider, I will put the arrows in such a way, so it will be easy for us to follow. So, first from the x we get R, Once we get, so this is a normalized one. Once we get the normalized one, we multiply R with the weights. So, the arrows here means that we are multiplying, and we get the multiplicative matrix which is Y, and we will check the second step here. So, I thought I will do the problems and then consider. Okay, by the way, normalization has been done in one way. So, just keep a look at the answer. So, I will just make it bold and also give a coloring, say for example, red. So, you will check the answers they change. Now, here the normalization was used, the value divided by the sum. What if we used the, so that was a linear part. Maybe I can use the quadratic one. So, the quadratic one with this value squared up divided by the sum of the squares, or if logarithmic one, log divided by the sum. Now, here if I use the square, so squared sum would come here. I will continue using the normalization factors here in the successive classes, but let me show you the normalization once more, other types. So, this would be square divided by not sum. So, it will be this square now 5 square plus square of 15 plus square of 20. So, these values, the column wise they are fixed as usual. So, it will be C2 fixed, C3 fixed, C4 fixed, C5 fixed, and this. So, these values are just copied. Again check the sum which is yellow in color. So, this comes out to be 1 as usual. If I do it for sum of the squares for this one, and also keep checking, because the video is there as you are watching, keep checking the values as they are changing on the red cell, which is Y, which I am multiplying. The weights I am not changed yet, let it be as it is. If I check the values now here, so it will be D, because I am considering the D column. D column is C2. C2 means criteria. So, C again I am repeating A1 to A4 alternative, C1 to C5 criteria. So, again copy it, just here it is D4. So, D2, D3, D4, D5. The value again comes out to be 1, remember here, which is in cell D13, where the cursor is. Similarly, I use the column E, which is corresponding to C3 criteria. I copy it, just check the value will come out to be 1 normalized. Similarly, I take it for F column, which is corresponding to C4. Again I add up, I like it is 1. Finally, I do it for G column, which is corresponding to C5. G, 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 So, if I copy it, again the value is 1, and if you have kept checking these values which are there in the red cell, which are multiplication of the normalized, and the weights keep changing. We will continue taking this from our end. I will save this file, this Excel file, so we can use that in the classes or the next one, and we will continue discussing about the TOPSIS and other matters. Thank you very much and have a nice day.